Hello everyone, I am Mrs. K. Vanitha, Assistant Professor working in the Department of EC at K. S. Rangasamy College of Technology. In this lecture, we are going to see about protocol layering and OSI model in the module Data Communications and Networking for the course Computer Networks. First of all, protocol layering. In data communication networking, a protocol defines a set of rules that both the sender and receiver and all intermediate devices such as switches and routers need to follow in order to make a communication to be more effective. When the communication is simple, we need only simple protocol. When the communication is complex, we may need to divide the entire task between different layers, in which case we need a protocol at each layer, so that protocol layering is needed. Can be explained by two scenarios. First scenario, assume Maria and Anne are neighbors with a lot of common ideas. Communication between Maria and Anne takes place in one layer, that is face to face with the same language. There is no need of securing the information. In the second scenario, they decide to continue their conversation using mail through post office. However, they don't want to reveal their ideas by other people. So they need to agree on an encryption decryption technique. We can say that the communication between Maria and Anne takes place in three layers. Layer 1, layer 2 and layer 3. At layer 3, Maria will be listening or talking and will be doing the opposite task. At layer 2, if Maria will be talking, and this will be the original text called as plain text, by means of encryption technique, it will be converted into ciphertext that cannot be accessed by an unauthorized person. And at layer 1, Maria will be sending the mail so that it will be posted through. And at the receiver side, that is Anne, will be listening that will be receiving the mail at layer 1. So the ciphertext will be decrypted at layer 2 and will be providing the plain text so that the original message will be received by Anne. So Anne will be listening at layer 3. So from this, we can derive two principles of protocol layering. First principle is that if we want bidirectional communication, we need to make each layer so that it is able to perform two opposite tasks in each direction. It can be given by Maria and Anne. Layer 3, at layer 3, if Maria will be talking, Anne will be listening. At layer 2, Maria will be encrypting and Anne will be decrypting. Maria will be sending the mail at layer 1 and Anne will be receiving the mail. So they'll be doing opposite tasks at each layers. The second principle is that we need to follow in protocol layering is that the two objects under each layer at both sides should be identical. The objects under each layer for example at layer 3 below layer 3 the information will be the plain text. Below layer 2 the information will be the ciphertext. Below layer 1 they'll be sending the mail. That is explained by second principle. So with this we can derive two network models. One is OSI model and the second one is TCP/IP, which is given by open system interconnection and by means of organization called as ISO. OSI model is a layered framework for the design of network systems that allows communication between all types of computer systems. It consists of seven separate but related layers. The seven layers are: the first one is physical layer, data link; second one is data link layer; third one network layer; fourth one transport layer; fifth one session layer; sixth one presentation layer; and the last one is application layer. The processes on each machine that communicate at a given layer is otherwise called as peer-to-peer processes, which means each layer in the sending device adds its own information to the message. It receives from the layer just above it and passes the whole message to the layer just below it. At the receiving machine, the message is unwrapped layer by layer. That is, until we get the data only meant for it. Interface, there will be an interface between these two layers. The 7 layers will be organized into 3 different subgroups. One is network support layer, second one is user support layer, and the next one is intermediate layer. The network support layer, if you are sending the data between two different networks, the first 3 layers will be involved. First layer is physical, second layer is data link, and the third layer is network layer. And if the layer 5, 6, 7 will be the user support layers, since it is connected to the users. Layer 4 will be the intermediate layer, will be acting as the intermediate between the network support layer as well as user support layer. An exchange of message between sender and receiver. At each layer, the information will be added with some more information. And at the last, that is second layer, data link layer, the trailers are added. So, and finally, at the physical layer, the first layer, which is given in the text, at the last layer, that is, and this is the data link layer, this is the physical layer. So, the data link layer, the trailers are added, T2, uh, as well as the headers. And at the physical layer, data will be converted into converted in the form of bits, and finally it will be transmitted through the transmission medium. Next, layers in the OSI model. The physical layer, first layer is physical layer. It is responsible for transmitting bit stream over physical medium, and also it deals with mechanical and electrical specification of the interface and transmission medium. The functions of physical characteristics of interfaces and media, representation of bits, data rate, synchronization of bits, line configuration, physical topology, and transmission mode. So with this, your data can be represented by bits and data rate, and how many bits will be transmitted per second, and there will be synchronization between the bits, and line configuration gives that whether we want to make a point-to-point communication or a multi-point communication. In the topology, in the sense we can have different topology: bus topology, star topology, mesh topology. The transmission mode will be the wired or wireless. Similarly, at the data link layer, shown in figure, will transform the raw transmission facility to a reliable link. So it makes the physical layer appear error-free to the upper layers. That is your network layer. Between the network layer and physical layer, data link layer will be available. The responsibilities of the data link layer are framing. That is, your physical layer will be sending the information in the form of bits, so that it will be added with some more information, that is headers and trailers, so that frame will be here the data unit will be frame, so that framing. Physical address, so we need to provide from which device the data will be coming and to which device data will be going. So sender and receiver information will be available in the physical addressing. Similarly, flow control, error control, access control are the responsibilities of the data link layer. Network layer, if yeah, if the two devices are on the same link, there is no need of network layer. But if the two devices are on the two different networks, we need to have a network layer with some protocol. So in order to provide source and destination delivery, the functions of the network layer are logical addressing and routing, which is used to perform routing of the information from one network to another by means of a router. And the transport layer is responsible for process to process delivery. So where the whole message arrives, it is responsible for checking whether the whole message arrives in order and intact. So if we have a large message, that will be segmented with different messages. So that's segmentation at the sender side, and which will be received at the receiver side, all and reassembled at the receiver side. So segmentation and reassembly are the important functions in the transport layer, and it will be checking whether the information will be received in the order it is sent from the sender side. So it is responsible for service point addressing, segmentation, reassembly, as well as connection control in order to make establish the connection, um, to disconnect also after communication is taking place. Flow control, error control. Session layer, it acts as a network dialog controller, and it establishes the interaction among communication systems as well as maintaining, synchronizing. All operations will be performed at the session layer. So it is mainly looking for dialog control and synchronization. Presentation layer, it is responsible for semantics and syntax of the information exchanged. So it performs translation, encryption, as well as compression if the data is large and to be secured. Application layer, it enables the user to access the network. Interfaces between user and the network. So it is acting as a layer between the user as well as the below layer, that is presentation layer. The responsibilities are network virtual control, file transferring, access and management, mail services, directory services. So far we have seen OSI model as well as protocol layering. With this we can have the MCQs that are OSI model. We will be having 10 MCQs. Look at these MCQs and we can have the answers during discussion. The OSI model consists of how many layers? The OSI layer is responsible for physical characteristics of interfaces and transmission media. Which OSI layer? The answers will be, the OSI model consists of 7 layers. The physical layer is responsible for physical characteristics of interfaces and transmission medium. Similarly, the data link layer provides and the logical addressing, routing or the main functions of which layer? Data link layer provides error-free link for transmission, logical addressing and routing or the main functions of network layer. Look at these 5th and 6th question. The layer responsible for end-to-end process delivery, and which layer is otherwise called as dialog controller? The answers are transport layer as well as for the dialog control it is given by the responsibility of the session layer. 7th and 8th questions are encryption and compression are responsibilities of, and also the OSI layer that enables the user to access the network services. The answers are encryption and compression are responsibilities of presentation layer. OSI layer that enables the user to access the services is application layer. The last two, which 3 OSI layers are otherwise called as network support layers? In OSI, a trailer is commonly added at which layer? The answers are the network support layers of physical data link and network, since it is connected to directly to the network. We also have seen user support layers. The last 3 layers, that is session, presentation as well as application layers, are user support layers. In OSI, trailers is commonly added at data link layer. Thank you.